Hey guys, how you doing? This is Coach Scott, and let's move on in our study of molecules. So now we're going to talk about double and triple bonds. So we've learned how to draw a Lewis structure, which is really cool, and I think most of y'all have picked up on that very well. So now we're going to figure out how, when we draw Lewis structures, that we don't have single bonds, right? We're going to have a double or a triple. So when we do our Lewis structures, and when we find our number of valence electrons and we put them on, we can find out that, we may run out of electrons, all right? And before the central atom has an octet. If that's the case, we're going to form a multiple bond, all right? Either a double or a triple bond. So here's an example. We've got hydrogen cyanide. So let's see, what do we got here? Let's see, we've got, put my pen on. Oh, let's use purple. So we've got hydrogen, and that's one, got a valence of 1. We've got carbon, it's got 4 electrons, and then we have nitrogen. So 1 plus 4 plus 5 is going to equal 10 electrons. Well, maybe I can draw that. There we go. So if we draw this out, it looks like this. We're going to put the central carbon as the central atom, just like we did right there. Get hydrogen there, all right? Then we're going to attach our nitrogen. Now, since that's an exterior atom, we're going to fill that up with their electrons, right, until it's got 6. Now let's go ahead and count and see what we got. 2, 4, 6, 8, 10. Whoa, we've used all of our electrons. But carbon still does not have a full octet. So just like this drawing does right here, we're going to take those pair and we're going to move them right there, which means they're going to be shared with nitrogen. So because we're sharing a pair of electrons, that's a bond. So that's how we get a triple bond right there. Okay, sort of cool. But again, if you follow the rules, we'll be good. So atoms will form a double or triple covalent bond if they can obtain a full energy shell by sharing 2 or 3 pairs of electrons. Again, it's trying to get the electron, all right? It's trying to get that full octet. So a bond that involves 2 shared pairs of electrons, we call it a double covalent bond. If a bond has got 3 shared pairs of electrons, we call it a triple covalent bond. So in class with your computers, we'll open this up and play with it a little bit, but it's actually a pretty cool little activity. And you'll see that they're really not sharing, they're trying to steal the electrons from each other. They're little thieves. So anyway, when we add the additional bond between the same elements, it's actually going to shrink the length of the bond. All right, so of course triple bonds, because we're shrinking it even more, are going to be shorter than double bonds. And double bonds are going to be shorter than single bonds. So here's a chart of bond lengths. And this is in angstroms, which is a unit of measure, right? And we can look that up. I believe it's 1 times 10 to the minus 10th. Sounds right. Anyway, so a carbon-carbon single bond is 1.54 inches. A carbon-carbon double bond is 1.34 inches. And a carbon-carbon triple bond is 1.20 inches. Excuse me, angstroms. And you can see that we have a trend on all these type of single, double, and triple bonds. All right, as it gets as another bond, the length will actually shrink. So that's bond length. What else happens? Well, the bond energy to break the bond or create the bond, all right, is the more bonds, the greater the energy is required to break them. So to break a double bond requires twice as much energy. To break a triple bond requires almost 3 times as much energy. That's the carbon-carbon bond, right? If you look at the nitrogen bonds, okay, it really, a nitrogen triple bond, Man, that's 941 kilojoules. That's a lot of energy, right? That you're going to need to break that triple bond. Okay? So, that triple bond is a very, very, very strong bond. Okay, so how do we do this? Once again, let's practice following our rules. First, determine the number of valence electrons. We're looking now at CO2, carbon dioxide. So we got one carbon right there, and it's got 4 valence electrons. We've got 2 oxygens, and it's got 6 valence electrons. So 2 times 6 is 12. 12 plus 4 is 16 electrons. So we're going to take and form our single bonds. Let's see if I can just move this. I can't, so we're not going to, let's see, let's ungroup it. Because we're going to fix it up, right. All right. Well, it's not letting me, but that's okay. So I'm going to draw it like so. Oxygen, well, if it lets me draw, oxygen, carbon, that's my central bond, and oxygen. Okay, so let's see, there's 2, 4, 4 electrons are used. I've still got, like what, 12 pairs? So I'm going to place lone pairs on my oxygen atoms. That's going to give me total number of electrons. Again, we've got 16 to fool with. So there's 2, 4, 6, 8, 10, 12, 14, 16. Cool, I've used all my electrons. But not cool because I've still got carbon with only 4 electrons around it. It needs 4 more electrons. So that tells me that they're going to be sharing a couple of electrons. Actually, 4. So this oxygen is going to, we did use those 16 electrons. So we're going to move that pair right there, which gives me a double bond. And of course that oxygen is going to donate its pair, and it's going to then share the electrons with the carbon. Now we see that carbon has 8 electrons around it. 2, 4, 6, 8. That makes carbon happy. And we like carbon to be happy. So now we've got 2 double bonds there. Notice that a double bond is using 4 electrons, 2 on each side. Right? So that's 2 and that's 2. Each line is a pair of electrons. All right? And of course we have to live those into oxygen. But oxygen's still happy. 2, 4, 6, 8. It still has 8 electrons. So everybody's happy. And we have 2 double bonds. So let's look at oxygen. Now I think I played with you guys with this today. So I've got oxygen, oxygen. Let's see what our number is. All right, O2. So oxygen has 6 valence electrons. We got 2 of those. 2 times 6. That's going to get, maybe I can draw 6. There we go. Equals. It's not letting me. 12. All right, we're going to pause and I'll see if I can fix this right on up, okay? Okay, got the problem fixed, so this is where I'm at. So we're drawing O2. Again, there are 12 electrons we have to use. So I'll put my single electron in there, and that gives me my single bond. There's 2 electrons. Let's start filling those up. 2, 4, 6, 8, 10, total 10, 12. Oh, that's not any good. 2, 4, 6, 8, 10, or excuse me, 12. That's not any good because I've already used my electrons up, and that oxygen only has 6. So what that tells me is this pair right there is going to be moved right there until it has a double bond. So our final structure is going to look something like this, with 2 lone pair of electrons around the Lewis structure. Okay, follow the rules and we'll be fine. So let's look at our next one. There we go. Well, it's nitrogen, Okay, N2. So nitrogen has 5 valence electrons. There's 2 of them, so there's 10 total to fool with. Draw my nitrogen. Okay. Let's put 1 bond in there. So now we start to fill it up. Okay, so there's 2, there's 4, there's 6, there's 8, oops, there's 10. Used them all. Well, that nitrogen needs 2 more pair in order for it to be happy, or a total of 4 more electrons. So we'll take this pair and move it right there as a bond, and it shares that one. And then let's take that pair right there and start sharing that. So let's clean it up a little bit. I've got a triple bond, nitrogen, and 2 lone pairs on each end. And again, by knowing what my valence electrons were I had to fool with, and I keep a count of them, I can tell what type of element we're actually making, or what type of bonds it's got. Let's look at carbon monoxide. So carbon is 4. Okay, there's 1 of those. Plus oxygen 6. That means 10. So we're doing carbon monoxide. All right, let's do carbon. There's oxygen. There's no central atom because there's only 2 elements. So let's start filling it up. So we've only got 10 electrons to fool with. So I'm going to put, there's 2 right there, of course. 2, 4, 6, 8, 10. So carbon only sees 4 electrons. It needs 4 more, so we're going to make a bond right there. Move that pair of electrons so it's sharing. Then we'll take this pair of electrons. All right, so they share. Okay, so that means, let's clean this up. I've got a carbon with a triple bond going to the oxygen. All right, with 2 lone pair. So that